So glycogen, remember, is just a string of glucose stored in liver and skeletal muscle. So mainly in liver, skeletal muscle. And we have to know how you make it and how you metabolize it. So making it is called glycogenesis. So we start with one of those intermediates that we had in glycolysis, which is glucose 6-phosphate. So we have glucose 6-phosphate, and we turn it into glucose 1-phosphate. Oops. And the enzyme that does that is phosphoglucomutase. So a mutase just moves that phosphate group from the 6 to the 1. And then we just add it to the glycogen via glycogen synthase. So this is going to be our key one, glycogen. I'll do it in green. Too much blue. Glycogen synthase. Now, is insulin going to stimulate or inhibit this?
Inhibit it or stimulate it? Stimulate.
Tell me, pick whatever one you pick it, and then tell me why.
So insulin's going to be the negative allosteric regulator, right? No. I think positive. I think it's positive.
So just tell me what makes sense to you. When would we want, like, think big picture here.
Mm-hmm.
When would we want to add to glycogen? So basically we have two states here.
Mm-hmm.
We have an anabolic and a catabolic state.
Mm-hmm.
Right? The anabolic state is when we're eating, we're building up, we're building things, we're eating. The catabolic state is when we're breaking down. So insulin is released in which state? Anabolic or catabolic?
Catabolic, right? I feel like I'm confusing it.
Yes.
Like, I do know it, but
So is insulin released when we eat or when we don't eat?
So when we eat.
When we eat, right.
Yes.
So insulin is released when we eat.
Yes.
When we eat, that's anabolic. We're building.
Yeah. Okay.
So eating is building. So is insulin then going to help us build glycogen?
Yes.
Yes, it will, right? Because blood glucose is high, we have blood glucose, we want to store it.
Yes.
So insulin's going to be our friend here in glycogenesis. Right? And that kind of line of thinking is the best way to remember all this stuff.
Okay.
Because for the MCAT, there's just too much to remember. So just being able to go reason through first principles like that, okay.
Mm-hmm.
Basics, anabolic, catabolic,
Mm-hmm.
eating, fasting.
Mm-hmm.
And then think, okay, insulin gets released, so it's probably so it's going to activate these pathways.
Mm-hmm.
That's going to be your most effective way of thinking.
Okay.
Forest instead of trees, instead of trying to memorize every little thing. I struggle with that too, you know.
Yeah.
Like I study science too and studied for the MCAT too, and it was like, no, I have to memorize every little
Yeah.
detail. But it just doesn't work,
Yeah.
is the thing.
Yeah.
It just doesn't work, because the MCAT will give you, most of the time it'll give you the details, actually.
Yeah.
And then it'll ask you about the concepts. Okay, so insulin and then glucagon will inhibit. And then the opposite is true for glycogenolysis. So glycogenolysis, we start with glycogen. Then we have the enzyme glycogen phosphorylase. And for this one, we have glucagon stimulate. Glucagon. And insulin will inhibit. And then glycogen. So we talked about a kinase, which adds a phosphate group, and then we talked about a phosphorylase, which removes a phosphate group. So it removes that phosphate group, and then we get the glucose 1 phosphate cleaved off, and then it gets isomerized to glucose 6 phosphate via the same enzyme, which is this phosphoglucomutase. Now, there's another key enzyme here that's going to work with glucagon. So let's think about when we want to break down glycogen. Like exercise, right? And in the ancestral environment, exercise meant running from a tiger.
Yeah.
What other hormone are we going to release in that stressful situation?
Is it adrenaline?
Adrenaline, exactly, adrenaline.
Yeah.
Right, and so in biology we call it epinephrine. So here it's EPI, so epi is going to act with glucagon. So glucagon's friend here is going to be epinephrine or adrenaline. Awesome. Awesome. So epinephrine is going to help break down glycogen, and it's going to inhibit the synthesis of glycogen. Right, so again we have reciprocal regulation. So these pathways are both happening at the same time. It's not like one or the other. They both can be happening at the same time, and then it depends on the hormonal environment as to which one is favored. And so remember, when glycogen gets broken down, only in the liver can this then be released into the blood. This glucose 6-phosphate that we make.
Okay.
Other times in the muscle, it just gets metabolized. All right. So that is carbohydrate metabolism.
Okay.
Hooray.